So we want to look at this problem where it talks about George buys a lottery ticket and each ticket has the probability of 0.3 of winning. So he buys a ticket each day for 5 days. And we want to know the probability that he has won at least one prize. Okay, so here's the deal. We know that the probability of him winning on a lottery ticket is a 0.3. And we know that he buys a ticket on day 1, 2, 3, 4, and 5. We want to know that he wins on at least one of these days. Okay, well, maybe he wins on this day. Or maybe he wins on this day. In other words, here's one possibility. Here's one possibility. Or maybe he wins on this day. Or maybe he wins on this day. Or maybe he wins on this day. Or maybe he wins on this day and this day. Or maybe he wins on this day and this day. It's very difficult when we want at least one to look at all those possibilities of I want this one, or I want this possibility, or I want this one. Anytime that we're looking at an at least one, remember that all probabilities have to add up to a 1 total. All the sum of probabilities adds up to 1. So at least one time of winning. Well, the only time that that is not going to happen, one time of them winning, is if he loses all 5 days. He didn't win here. Any other time, if I replace any one of these with a W, then that means he's won. At least once. So the only time that that will not count is if he loses one time. Well, we know that the probability of winning is 0.3. So what's the probability of a loss? Well, it's 1 minus the 0.3. So that's a 0.7. So each one of these days has a 0.7 chance of losing. But I want him to lose day 1, and day 2, and day 3, and day 4, and day 5. So what I'm going to do is I'm going to take 0.7 for day 1, 0.7 for day 2, 0.7 for day 3, 0.7 for day 4, and a 0.7 for day 5. Because I want him to lose each of those days. And I'm going to multiply that because I want all of these things to happen. It's not an or. It's not he loses on day 1 or he loses on day 2. I want him to lose on day 1 and on day 2. So if I multiply all these, that's the same thing as a 0.7 raised to the 5th power. Well, technically we don't want this number. We actually want everything else except this. We want everything except that, so what we're going to do is we're going to do 1 minus this value. So if I take 0.7 and I raise it to the 5th power, I get a 0.16807. And if I do 1 minus that number, I get a 0.83193. And if I round that to 4 decimal places, it'll be a 0.8319. Anytime that you want at least 1, what you're going to do is you're going to do 1 minus none. So you're basically looking at 1 minus the probability of the opposite raised to the power of the number of times. This is what you're looking at anytime that you're wanting that probability of an at least once. You always want to go to the opposite. So in our case, we were looking at the probability of winning, which was that probability of 0.3, and we were looking at 5 days. So we went to the opposite of winning, which was losing. So if we had a probability of winning of being 0.3, opposite of that is losing, which would be a 0.7. And we're going to do that for 5 days. So we're going to do 0.7 for 5 days. And then we're going to do a 1 minus. And that's going to give us the 0.8319. So anytime you want it at least once, this is what you're going to work with. If you have more questions, let me know.